On the last page, we did already fill out this chart for the different atoms and the subatomic particles in there. So we are starting on page 4 with atomic mass. This term I generally will refer to as the average atomic mass instead, because I think that it's a little bit confusing to have atomic mass and then your mass number as 2 separate things. But the reason I call it that is because it is the weighted average of the mass of all the isotopes of an element. We express it in AMUs. Sorry, you can't see that. AMU stands for atomic mass unit. So if you're measuring atomic mass, you're going to use the atomic mass unit. That's the easiest unit we'll use all year. A proton is the equivalent of 1 atomic mass unit. A neutron is the equivalent of 1 atomic mass unit. And an electron is the equivalent of 0 atomic mass units. So without using actual math, up until this point, we've already been using these to calculate the mass number of a specific atom. Usually, your average atomic mass, or just your atomic mass, is not a whole number since it's a weighted average of the isotopes. And then the way that we will calculate it, I'm going to abbreviate it as average atomic mass. We will calculate this by taking the percent abundance times the mass of that specific isotope plus the percent abundance times the mass of that isotope plus however many there are. So for different elements, there are different numbers of isotopes. And this is where we will focus our attention on Monday for our Beanium lab. The note that I want to put on here for you is that your percent abundance, when you multiply it by the mass, it needs to be expressed as a decimal. So what that means is if it's given to you as a percentage, you will either divide by 100 or move the decimal to the front 2 times. So put on here a note as a decimal. And then here, same thing, as a decimal. So some of you may know, some of you kind of struggle with this, that a percent literally means out of 100 or per 100. So if I have 75.77%, and then I type that into my calculator, 75.77 divided by 100, it will just move your decimal twice. So this number, written as a decimal, is 0.7577. This number, written as a decimal, would be 0.2423. Where it gets really confusing for students a lot of times is if I have something like, this is not related to the question, but 4%. To express that in decimal form, you would need to move the decimal twice, and if your decimal's here to begin with, that means that you're putting an extra 0 in front of the 4. So this would equal 0.04%. Or something like, sometimes it can be 0.0, not percent, sorry. Messed that one up. 0.04 as a decimal, that's the percentage part. Sometimes you'll have a fraction of a percent, so like here, on our previous page where we had 0.12%, that is less than 1%, but I still need to move my decimal twice, so to express this as a decimal, it would be 0.0012. If you are not sure, you can always type it into your calculator and just hit divided by 100. So percent means divide by 100. So what this will look like, sorry, my zoom is all weird, is when I plug it into my equation, my average atomic mass is equal to my percent abundance of my first isotope. So it says calculate the average atomic mass for chlorine if it contains 2 naturally occurring isotopes. Chlorine 35 has this percent abundance, so I'm going to do 0.7577 times 35, because that's the actual mass of the isotope. And then add to that 0.2423 times 37, since that's my second isotope. A couple of notes are that your percentages should always add up to exactly 100%. And your final answer, when you're looking at it and trying to determine if it's realistic, your answer should be between the numbers of all of the isotopes that you have. In this case, chlorine 35 is much more abundant than chlorine 37. So our final answer should be closer to 35 than it is to 37. And then when we're done calculating it, we express it in the atomic mass unit. So whatever that number is something AMU. So I'm going to pause and give you a second to calculate this yourself, and then you can also set up letter B. For example A, what did you calculate as your answer? 35 point what? Do we agree? Oops, 46, sorry. 35.4846. I think that's right, right?
That's what I have.
All right, in example B, did you already set it up yourself, or do you need me to give you more time for that?
I set it up.
If you haven't set it up yet, go ahead and do that. Don't forget to move the decimal for both of your percentages. All right, example B, if we set it up, we're still using our average atomic mass equation, where I'm taking my percent abundance of my first isotope, which is copper 63, which has an abundance of 69.1%. I would move my decimal twice. So I would write this as 0.691 times the mass, which is 63. Add to that the percent abundance of copper 65, which would be written as 0.309 times 65. When I actually calculate it, what do I get? For the second one.
I know, but like, which one on the second one? Like the first one?
Oh, when you get the whole thing. So you can type this all into your calculator. If you press the exact buttons in the exact order that it is on there, you can type it all in at once. So if I type in 0.691 times 63 plus, open parentheses, 0.3, sorry, I keep typing wrong, times 65. If I could actually type it in correctly, it'll give you the right answer. Good. 63.618 is the right answer to this. You can get it by typing it all in at once like that if you use parentheses. Otherwise, you can calculate this part, and then add them together at the end. Whatever you prefer, just be careful with your typing. So 63.618. And what is our unit? We calculated the average atomic mass. What unit do we use for that? AMU, the atomic mass unit.
Does it matter if the A is capitalized?
No.